he came to a conclusion which I think everyone would agree is somewhat unrealistic, even though he showed it worked. He said, you have no choice, you have no choice. You have to, if you're serious about it, learn the science. So, well, how? He suggested, well, you know, he's not a scientist. He suggested the following method. He said, look, you know, maybe you can't do it yourself, but you have a church group or something else, they're interested in it, divide up the task. But you have to go to the scientific literature. Journal of Climate, Journal of Atmospheric Sciences, these things, not science and nature. He said, you're going to have to pick some article and read it. He says, he understands, you may not understand a word of this article, but if you try and read it, you'll find a sentence every so often that you understand. Write down that sentence. As you finish the article, there'll be several sentences you've written down. You'll have some idea of what's going on in the paper. Then the paper will have referred to other papers, go on to that. And he said, after you've done this for 20 papers, you'll actually find you have a pretty good idea of what people agree on, what they disagree on, what are the arguments, what are the things they leave up true. He said, at that point, you can call one of the authors. He said, don't worry. Any scientist who finds you're trying to read his paper will be flattered and try and answer you. So he did this with his class of political scientists at Berkeley. And he assigned each of them a different environmental problem and said, follow this procedure. And that's the book, but is it true? And the articles, I don't agree with them all, but they're among the best articles I know of in the popular literature for each of the topics, acid rain, other things. So the method worked, but I've never found anyone who wanted to follow it. The question is, so if you don't want to do that, what can you do? And what I'd suggest is, at least learn what science is, not necessarily climate science. Try and be logical. Let me give you some examples. There are certain statements you will hear that should immediately provoke your suspicion, no matter who says them. One is when somebody claims science is incontrovertible. A red alarm bell should go off. And it should go off because, by definition, nothing in science is incontrovertible. The person has left the realm of science. The other thing is, when you hear somebody arguing from authority, this is a propaganda tool. You can argue about science, you can argue about scientific principles, but authority in science is usually a device for dealing with the fact that most people don't want to deal with science. So for instance, when global warming, which had been on the environmental horizon already for 10 to 15 years, broke into the public eye in the US in 1988. Some of you may remember, I find it astonishing personally, when I ask people how long has this issue been around, the typical answer I get is 3 years, 4 years, since Gore's movie. Now, in the intervening years, after 1988, the New York Times was averaging 2 articles a week on this and had one reporter, Bill Stevens and then now Andy Revkin, on the global warming beat. And yet, it still had not struck people that this was an issue until the pressure was really built up. In any event, the first issue of Newsweek on this declared all scientists agreed. At that point, hardly any scientist even had an interest in this problem. And to the present day, the vast majority of scientists don't work in this area and have no knowledge of it. But what is the purpose of telling people all scientists agree? It's to say, you know, you don't want to deal with this. Isn't it enough to know all scientists agree, now you don't have to deal with it? And so, be suspicious of that. Now the other thing that you might wonder about. At least in my experience, if I ask people, please tell me, what do you think global warming is? I find most people have no idea. And that has something to do with warming. Now it's climate change. But it actually has to do with a single obscure number. And that is something called globally average temperature anomaly. Now, what is that? Actually, for instance, averaging temperatures over the globe is meaningless. That's like averaging phone numbers. But what they do instead is say at each station we'll take a 30-year average, let's say 1950 to 1980, and we'll ask how much did the temperature each year vary from that average. That's the anomaly. And we'll average these deviations over the whole Earth. Okay, when you do that, you get a big scatter diagram. Things are varying 4 or 5 degrees. And it averages to as close to 0 as you would wish. You look at the graph on the same scale, and it looks, just a lot of noise. And then you stretch that graph 10 times, so that now it looks as big as the original one, but it represents only a tenth of the change in temperature. And that's what you've been looking at. So now we're looking at tenths of a degree in this quantity. Tenths of a degree vary from year to year. We've got a half degree varying from 1919 to 1920. There's nothing impressive about it. The Earth, by that standard, is always cooling or warming. If there's anything unusual, it's the last 10 years when it seems to be doing nothing. If you looked at the data, you'd realize this is nothing to be worried about. Instead, you're presented this crazy notion. Is it warming or is it cooling? And as soon as somebody says it's warming, that's bad. The question in science